For those of you who like an animation, let's do an animation of Grace hash join. Again, we have two phases, the partition phase, which is a divide, and the build and probe hash tables phase, which is conquer. So in this example, we have R in blue, we have S in orange, and the join keys are represented by shapes, by colored shapes. And so we're going to be matching up tuples based on their little shapes. Okay, so that's the animation. We have B buffers of memory here in the middle. One buffer is being used for input and B minus one buffers for partitioning. So first we're going to partition S. We read in a page of S. We use the hash function to put its tuples into output buffers. We read another page of S. We use the hash function again to put its tuples into output buffers. You can see that if tuples match, they end up in the same partition. And when buffers fill, we push them to disk, and we generate new buffers as needed, and we spill them to disk as well. Okay, and so we've partitioned S. Now we'll do the same thing for R. We read one page in. We use the same hash function to partition it. So the stars go to the top and the squares and circles go to the bottom. Get the second page of R, partition it, and we write our outputs to the matching partitions of R that go along with the partitions of S. And so you can see we have divided our problem into separate partitions that we can now join up using essentially naive hash join in the second phase. Note that each key in the first phase in partitioning is assigned to exactly one partition. All the green stars are in partition 1. And another thing to note is that hashing is sensitive to key skew. So that fuchsia circle key on the bottom has led us to have more keys on the bottom than the top. The round circles are pretty popular. And so that's always something to watch with a hashing algorithm, is whether you get skew on duplicates. Now note that these partitions don't have to be on the same disk. They don't even have to be on the same machine. We could do these second phases on completely different machines. We'll talk about that soon as an opportunity for parallelism. But for now, let's focus on a single machine. And now we're going to do the second part of the Grace hash join, which is the build and probe phase. And so we're going to build on relation R. And so we read a page of relation R from partition 1 into memory, and we construct a hash table out of it. And then we take the probing relation, which is the orange relation here for partition 1. We read in a page of that, and for each tuple of that, we're going to look for matches in the hash table. And when we see a match, we'll concatenate the tuples and add them to the output. And of course, when the output buffer fills, we're going to have to flush it to disk. And when we're done with partition 1, we're just going to do the same thing for partition 2. So we build a hash table again on R, one page at a time. The hash function in memory is going to make sure that all the matching tuples are in the same hash buckets in memory. And now we probe with pages of S, and we form matches, concatenate them together, and put them in the output. Flushing the output, of course, whenever the output buffer is full.